Okay, so this is problem 2A from exam 2 on in the kinetics section. So the first thing about this is what exactly do we want to do? So we want to identify what equation we're going to use. And because we're given you can see that we're given the graph of ln k versus 1 over t, and you get y equals negative 10,697x plus 26.561. You're also given a collisional frequency factor and the activation energy. This is in line with the Arrhenius equation, which relates temperature and activation energy to a rate constant. You have k, ln k in this case, being the rate constant. You have EA being the activation energy. You have R, which is a constant, the universal gas constant in particular, being 8.314 joules per moles Kelvin. And then you have 1 over T being your X value. And A at the end is a collisional frequency factor, which is unitless and is essentially expresses the probability around orientations and collisions, and is a collisional frequency factor for the molecules in your reaction that will be different for any reaction. So we've identified what equation, and we have the original y equation, so now we can move on. We can say ln A, which is the end, is going to be equal to the 26.561, because that's equivalent to our B in this situation. So then just going from there, you just you do each side of e to the blank to undo the ln. So in this case, it's e to the 26.561, and that's how you get your answer, which is going to be 3.43 times 10 to the 11th. But that's only for the first part. That's just finding the A in this, the collisional frequency factor, as you're given it. And so you want to confirm it. Next, you can see EA is over R, which again, this time you're going to change from joules into kilojoules. So it's 10 to the negative third, which is just an easy way to do that because it's 1,000 joules in a kilojoule. And you have negative EA equals negative 10,000. So you can just divide both sides by a negative version of the R value so that you don't have to divide by negative 1 afterward. You can see you do that there, and that's going to get you your value. So next we're going to move on, and we're going to try and figure out the K value at a certain temperature. And because, again, that's our X value, we can keep everything the same from the original Y equation, except we're plugging in ln K instead of Y. And then instead of X, we put 1 over 77 plus 273 because you have to change it to Kelvin. From here, you just solve. And then once again, to undo a natural log, you're going to want to do e to the power of your thing that equals the natural log of your variable. So from that, we get our final answer. And these are our 3 final answers for each of the ones. We have A is a factor, which is a unitless. It is the collisional frequency factor. We have EA, which is activation energy, which is going to be in kilojoules per mole, which again, we wanted to get that into kilojoules when we were doing it. And then we have ln of K, which is the rate constant for the reaction, which in this case, when you cancel out all the units, is 1 over seconds.